Alright, so here is the problem 3 itself, and we're gonna go through a solution of this problem after this theoretical basis related to a mixture of gas has been recapped, and make sure you understand that. Basically, we use the gas state for particular component and for the whole, for the whole mixture. Okay, so make sure you understand that. And that was the Dalton law, actually, about the pressure. So here's the formula related that the total pressure is the sum of the pressure of each component. So if not, just try to watch this video one more time, it's pretty short. And here's the problem itself. This problem represents the whole class. We have a mixture of gases, and you need to define probably a ratio or ratio, for particular components to the total mass. Or probably you need to define molar mass, mu for let's say for a mixture. Okay, pause the video, try to do it by your own, and let's get started. Alright, so because we need to find molar mass of a mixture, we can straight go to the equation for the gas state. So equation for the gas state, and just put as the total mass that will represent, in our case, mass of the oxygen and helium, so it's going to be M1 and M2 together. So I just marked O2 for the first component and helium for the second one, but I will use notation as M1 and M2. Alright, so what we can say about new number of moles, the same is going to be nu1 plus nu2. Alright, and that means for the pressure we have the same P1 and P2, that the resultant pressure, so we can put the equation for the gas state for the mixture, okay, for the mix. And let's put it down. So PV is M over molar mass. We use definition of number of moles, mass over the molar mass, and times RT. Alright, so from here we can express our molar mass, because definitely we're given the mass, the total mass, which is 10 grams. Now just put that down. So we have total mass of 10 grams. Okay, we have volume, which is 30 liters. Well, we can convert into cubic meters, 10 to the negative 3. So that's how we will use that in cubic meters right now. And so we have the pressure. So pressure is going to be 1.8 atmosphere, or in pascals it's going to be times 10 to the power 5. That we're going to have right now. So pascals, and alright, and that's enough. So we express molar mass as mRT over PV. That's how it looks like. So we've got it in one simple step. So we have R, that's the constant, 8.31. We have temperature, but we need to convert into kelvins because we're given 30 degrees. So that means right now we are going to add to 273. So 273 plus 70 will have 303 kelvins. Alright, so that's our input data, and now we can fully use that in order to calculate molar mass. Alright, so let's do that. Take your calculator and let's do it with me. So I'll use in grams per mole, so that means I just plug the values. After calculation, 10 times 831 times the temperature, which is 303, and over 1.8, 10 to the power 5, and because we converted volume, it's going to be 30 times 10 negative 3 cubic meters. All right, So that is proper right now, and we can figure out the value for molar mass. So it's going to be 4.7 grams per mole, all right? Grams per mole. Okay, so that's the final result for the molar mass, and we can move on to part 2. So now we know that the molar mass of the substance becomes 4.7. So by the way, I will indicate molar mass for each component. So molar mass for component 1, which is O2, becomes 32 grams per mole, right? So make sure you understand that oxygen is in a molecular state, so that means we need to use twice the mass of their atomic oxygen. So the same as for helium, not the same, but for the helium we just use atomic helium, and that means we have 4 grams per moles. All right. So looks like more the quantity for the oxygen due to their molar mass is 4.7, and it's going to be quite small, so we'll see that soon. All right, and we're gonna go to part B. So in part B, we need to calculate. So sorry, for part B, we're going to calculate hence or otherwise the ratio of the mass of components of this mixture. So basically we need to figure out M1 to M2 or vice versa. Okay, so that's our target, and obviously what we can do, we can create a separate gas state equation for each component. So that means we've got P1V, so we can add them up. So I think obviously we can use the total pressure which we are given and the total mass which we rewrite as through each component. All right, so I hope you understand that. It's going to be the sum of those ratios, basically the sum of quantities of the substance, and we can use that. All right, what I'm going to do, because the total mass is M1 plus M2, we can try to express M1 through M2. So M1 is the difference, and we can use this and plug straight into this equation. So we have PV, so we have PV over RT will be equal to, so M1 is this ratio, so we can use M2 molar mass and plus M2 factorized, so and here's going to be mu2 and mu1, and here is going to be the difference, I guess, mu2 minus mu1. So let me see. Yeah, I guess mu1 minus mu2, yeah, this way around. Okay, so we express, and right now what we're gonna do, we just need to probably, instead of PV over RT, use molar mass, because right now we know that molar mass is M times RT over PV, just what we expressed before, it's right there. So using the formula 1, we can express molar mass, so that means PV over RT simply represent mass over the molar mass, and we can plug in. So hence we have the following equation: over the molar mass minus M over mu1 is going to be M2, and here is going to be the difference, mu1 and mu2. So here you need just be very precise in what you're doing and accurate here. So right now we actually do the following. So we need to express M2, and I'll do it very quick. So M2 is going to be, Here is the difference, so we can use the total mass times mu1 minus mu over difference of each components here, and mu2 over mu. All right, so that's what we're gonna have. Okay, yeah, it's fair enough. So mu2, so as you remember, for mu2 we have 4 grams, yes, so that means mu1 is going to be 32. The difference mu1 minus mu is going to be positive, right? Because it's literally, let's say it's 32 minus just 4.7 grams, and that's definitely positive. All right, so I bet that we should have similar, so we can do the following way. We can plug m2 right here into the equation for m1, so right there, and just simplify. But I bet that it's going to be the following structure. Obviously mass, because it's mass based, and here we need to have the right proportion, so I'll write mu1 minus mu2. Instead of mu1, that's going to be mu2, but because mu2 minus mu is going to be negative, right? So obviously they should be positive values, so mu minus mu2. That's what I bet is going to be. And instead of mu2, we are going to use mu1 to the total mass, molar mass. All right, so I hope that this is going to be the final set of formula for mu1 and mu2. And the rest part, what we need to do is to find the ratio m1 to m2. Okay, so let's do that. Simply just divide m1 by m2 in order to have a proper way. Okay, and we have mu1 to mu2. I just divide the right sides of that, and also we will have mu1 minus mu2 will be cancelled, so we'll stay with mu minus mu2 over mu1 minus mu. Okay, that's what we're gonna have in the end. So one more time, just let's put in frame, indicating that we've got the, literally the formula for that. So in case of other numbers, I hope you understand that you just need to plug in. And right now, if we calculate that, we should get 32 over 4, and here is going to be the difference, yeah? So 4.7 minus 4, and over 32 minus 4.7. All right, so those numbers will lead us to the ratio m1 to m2 as around 0.21, and that's going to be the final solution here, numerical solution. I hope it's not really hard for you guys, because we'll just based on the principle of the mixture. So basically those pretty easy principles that I clarified before, and we've got a solution for part A to where we're supposed to calculate the molar mass of the mixture, and finally the ratio of mass for components. Hope you like that. So probably I'll just discover more about when you have mixture of gases and they leaked. So the one portion of that mixture just leaks into another vessel or another tank and occupy those space there. So I'll see. Okay, hope you like that. That was pretty nice demonstrations of the class and possible questions. So make sure you get prepared well for this section, and we'll move next.